Hey there YouTube, this is SJM4306, and that shot would have been perfect if I didn't have it upside down. But anyway, you can see my next teardown item. I just got back from the thrift store, and I gotten this speaker. I needed some small speakers for the tabletop arcade system that I'm building. So I got this for, I think, like $3 or $4, probably around $3. It was on sale, and it was like a clearance item. They have random sales at the thrift store I go to, and today it just so happened to be purple tag items, and this was a purple tagged item. So this works perfectly, actually. There's absolutely nothing wrong with it. It's a radio, and oddly enough, it's a Zune. No content ID. So anyway, it has Zune auxiliary and FM radio. Really odd choice. You'd think they would have done an iPod one. But anyway, just need it for the speakers, and maybe I might scrap some of the parts. But what I wanted to do a teardown for you guys today is of this guy. This is a Brother P-Touch. It's a PT-1010. It's one of these label printers, and this uses thermal printing. So the cartridges for these, I have a sample one that it came with. Whoever the previous owner was had it. They're only like $3 or $4, and they come in all different colors. It prints black on white, white on black, different colors: green, yellow, blue, clear. So yeah, I'm probably gonna end up buying some because I have a lot of little mini discs, and it'll be nice to be able to print out the track information or whatever, the artist that I have burned on the mini disc on these, as well as I have a lot of these little containers that go in a shelf, and if I could print out a label of what the contents of that is supposed to be, that'll make looking for parts a lot easier. So I bought this for a grand total of $2.39. I love it. So yeah, just wow. I was gonna say take this off cleanly because it's on the seam where I need to unscrew it. Anyway, yeah, we'll take care of that later. So yeah, let's do a quick teardown of this. I'd previously printed out my obligatory Hello World to test to make sure that it worked. There were no batteries in it when I bought it, obviously, so it was a 50-50 chance that it would work. Here's the cartridges it comes on. They're a 1/2 inch or 12mm width. And yeah, this is a TZ tape, and I've yet to open this. I started trying to pry, but I was afraid I was going to break it, and this is the only card I have, so yeah, I'll probably hold off on opening that up. But we can open the main unit up, and one interesting thing is it takes 6 batteries. So this is the same exact technology that's in the Game Boy printer that I did a teardown of before, albeit this is a newer device. So yeah, it takes 6 AAA batteries. That's kind of ridiculous, or an AC plug. And we have a handful of screws here, so let's get to it. Okay, very carefully, let's lift something off. Something's gonna give. And it looks like the sides come right off. It's a pretty neat design. Sort of reminds me of the side parts on the Game Boy Advance. Also are kind of separate, the gray parts. And we can carefully separate this like a book. And we can undo this ribbon cable. I'm guessing that goes to the printhead, and there's some sensor wires here. So that is a huge capacitor. Wow. Yeah, one thing about thermal printing is it requires a lot of current because it has to heat up like a heated head that chemically changes the color of the paper that it prints on. So that needs a lot of current, which is why there are a lot of batteries. And if you'll notice, it looks like it puts the AA batteries in parallel. So this likely only runs off of like 4 or 5 volts, but it needs the current. Odd choice that they didn't make it AA batteries because you get better battery life and whatnot, but probably they just wanted to go with the smaller form factor. So yeah, you can see a small polyfuse in here. This is 6 amps at 250 volts, which is way overrated, but they just need this for some input protection. A huge capacitor, a diode probably for reverse voltage protection, another diode, and a small resistor in there. And yeah, so we have our main motor here. Sorry about that. So this is probably what advances the reel on this tape. And this is essentially, works almost similar, I guess, to like a cassette tape, where it'll spin this and it'll advance the tape. And then it spits it out the top, and then you have this mechanical bit here that just chops it. This worked actually really well. I was pleasantly surprised. I've never really used one of these before. So yeah, we have some sort of sensor here. If you can see, they're actually little pins, and there's a set of 4 of them. And there are some keys here. Very interesting. So I'm guessing, depending on which number and which pattern of these pins are pushed down, it can detect what type of tape, maybe what color, or what size, or whatever. So it can tell different cartridges apart. That's pretty neato. That's a simple way of doing that. So if we look through here, it looks like this is where the thermal head is. So maybe I can get a close-up. There we go. You can see it's a little dusty. And there's a flat flex ribbon cable, and then some kind of some black epoxy gook just to stick it down on a ceramic substrate. And if I could get very carefully, I might or might not remove this. I want to keep this in working order, but you can see on this other side here, you can see some kind of fine matrix pattern on like the metal substrate. And that's what creates the different dots on the printout itself. That's what creates kind of the dot matrix here. And oddly enough, yeah, it looks like maybe some dust got in there and it interfered with the way this printed. The only thing about this thermal tape is it doesn't last forever, and it will eventually fade itself. So yeah, that's just sort of the way it is. So this is a similar stuff to receipts, the way that they're printed on. And so here we have 2 screws, and then this ribbon cable that goes to the main button board, which is just a rubber membrane button keypad. So yeah, fairly simple construction. We have a crystal for the main processor, and for all you processor aficionados, this is a MN101C77F BB, and it's made in Japan. I don't know if that's the product number or if the LW1719-A is. Anyway, if you are interested in looking up the information on this processor, it's just going to be a microcontroller basically. And this is going to have all the font data stored in it, the menu system, as well as the software to actually control the printhead and the motor and whatnot. But for the motor itself, it's going to be likely driven by some sort of motor controller, not directly from here, as well as the printhead, the thermal head, is going to require more current than general purpose I/O is capable of driving. So there's going to be some interface chip. This might be it. It's a UTC BA6222OL. It's going to probably be some sort of like transistor Darlington driver or H-bridge or something like that to drive the motor and stuff. And we can see, yeah, right next to the motor terminals, a transistor Q4. This might be a regulator. I'm not going to look up the parts. Anyway, yeah, the circuitry is actually not that complicated. Interestingly enough, there's S1, S2, S3, and SC, SB. So there are these different wire links. I wonder if there are different models of this printer with different features, and all they do to unlock, they all have the same software, I wonder. This might be possible. And all they do to separate the different models is they put a blob of solder to bridge these. And so when you turn on the printer, it checks that. So I'm guessing maybe that's a way of maybe unlocking maybe for different regions. Maybe the same unit is released in America, Japan, Europe, or whatever. And so if they have, if you want different font information, instead of reburning this chip, maybe this will select kind of region or something like that. That's an interesting idea. I'm almost tempted to desolder one of those and solder another one, boot it up, and see what happens. Yeah, I'll try that maybe when I get more time. But yeah, I want to print out a whole bunch of labels first in case this stops working. Anyway, yeah. Other than that, we can take this guy off, 2 screws, and maybe lift the skirt on this main board here. There's no point in me pulling off the membrane keyboard board. Anyway, that'll just look like any old keypad. Anyway, just remove 2 screws so we can lift this board slightly. And okay, yeah, I can't lift this all the way because this is actually the LCD ribbon cable, and it wraps around under and to the bottom side of the LCD there. You can kind of see it right there. And that will be very fragile. If I do nick that, then this printer will no longer, well, it'll work, but I can't see what I'm printing then. And that would be no bueno. So I'm just going to leave her as she is right now. Just put those 2 screws in. Yeah, it's amazing what you can get nowadays. This was like $2, what, $2.40 or something like that. I mean, given it's used, and whoever bought it originally obviously got their use out of it, and that was it. But yeah, it's amazing what you can get at thrift stores and you know, garage sales and whatnot. That's awesome. Anyway, we have this main apparatus here. I'm debating whether I want to take this out because I have a feeling the way this is constructed, all these gears will be free floating in here, and as soon as I pull this plate off, I bet you all the gears and all the springs will pop out and go absolutely everywhere, and I will have a nightmare of a time getting them back in, because that's the way it works. So as for now, I think I'm just going to leave the mechanics all in there. I can already see some springs that are probably going to jump out, fly across the room, hit me in the eye, and you know, I'll have a bad day. Anyway, you can see there's a pincher roller assembly that engages when it starts sprinting in order to pick up the slack. There's another one here, sort of like a capstan, and then this is a mechanism. Maybe we can see. Oh no, you can't see. Maybe you can't see. I was gonna say maybe you can see the cutting mechanism, but that's probably tucked inside, so you can't get your fingers in there, and maybe it locks it for safety reasons. But yeah, that's pretty interesting. Everything, all the data is sent along these couple of wires, and this isn't that dense of a board. Actually, I might be able to program my own PIC microprocessor to control all this. It's just a motor, and I don't even really need an H-bridge since you only print in one direction. These not really necessary either. And there's only about 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 wires on this cable for the printhead. And that's it. That's all you really need. So yeah, I could actually make a little version of this that has a PIC microprocessor and like an OLED screen and make my own device. There's a little switcher actually I missed. Huh, interesting. So I guess this detects the cutter portion. Oh yeah, and there's a little piece there that prevents you from engaging it. It's like a safety mechanism. So yeah, you have to have a cart inserted to maybe undo that or something. Yeah, you can see it goes down here, and you can see the blades. There we go. So if I engage this, you can see this blade comes in right there. I'm not going to put my finger right in there, but that's how it cuts it. So yeah, this is actually a pretty neat solution, and yeah, I'll definitely have fun cutting lots of labels for my devices. Sorry about the autofocus not being focused. Anyway, yeah, so this was the teardown. There's really not that much in here. There's a small potentiometer next to what I presume is sort of a Darlington transistor or something like that for current handling capability for the head output, and I'm guessing that controls the current limiting. So yeah, there's really not a lot in here. This is a very simplistic board. So yeah, just gonna stick it back together and get to printing. Anyway, hopefully you like this teardown. I rambled on for about 16 minutes, but yeah. These are very simple devices. You can get them cheap because I guess a lot of people would just buy them once, use them with the sample card, and then realize, oh, you know, there's not a lot and I have to buy a new cartridge, and they throw it out or give it to a, you know, a thrift store. And that's where people like me get them for dollars on the, or pennies on the dollar, so to speak. Quick little addendum, this is fascinating. So I used up most of the tape. This was just a sample cartridge, just printing out these labels for my resistor box here. And so the cartridges are pretty cheap. They're about $3 or $4 off eBay, so I'm probably going to buy a couple more. But it's interesting, so essentially this is a laminated sheet. So there are actually two spools in each of these cartridges. One is a clear top layer. Here you can see that there's a sort of a pattern on here to show you that it's at the end of the spool. And so here's the actual part that it prints on, like the backing material basically. If I can zoom in. There we go. So you can see it's sort of sticky. Well, I mean, you can't see, but I can definitely feel it's sticky, and this is the other sticky side. So it's essentially like a double-sided tape. And so it'll print off that while simultaneously putting this top layer down so that it essentially creates like a sandwich. And so you can imagine that whatever color the backing is you know, is white or whatever, it prints black on top of it, and it sticks like a clear transparent sheet on top of it. So one thing that you might know about thermal paper is that it's rather sensitive to external, like, you know, temperature, anything chemical. If you put regular clear masking tape on a receipt, you'll notice that the text starts fading very quickly underneath where you put the tape, and that's due to the chemical reaction of whatever glue they use in the tape. So here they must be using something that you know, doesn't actually react with the chemical in the thermal paper. And so it creates kind of a sandwich to protect, and it's laminated. So this should last, you know, quite a bit longer, however long, you know, kind of the shelf life of the actual particulates in the thermal paper last. So that's really fascinating. I had no idea that. I thought it was just kind of, I don't know, like a single material and it printed through the outer layer or something like that. But no, it actually kind of sandwiches it in between two protective layers with the paper backing with the adhesive. So that's really fascinating that there's kind of a lot going on here. And yeah, basically it just goes around here and it peels off this paper and kind of tapes it as it exits out. And this is the area where the printhead is, where it's exposed, the paper before it puts on the outer laminate, it's exposed so it can print it before it actually gets taped together. And there's a take-up spool here as well. So yeah, this is fascinating. I'm going to buy some more of these probably. Well, number one, because I need to finish printing the labels. And another thing is I noticed on this printer, there are actually a couple different modes. You can have it so it'll print out specific length for VCR tapes, DV tapes, audio cassettes. It has like a neat little feature where you can do that. It knows how much to print out in order to fit the right length. So yeah, that's a pretty neat feature. One unfortunate thing though is, so I can get it to not print out this extra wasted material on the back end, but it always seems to print out wasted material on the front, about, you know, this length here. So about 3/4 of an inch, which is kind of unfortunate, but given how cheap this tape is, you know, not so bad. Anyway, hopefully you guys enjoyed this addendum, me cracking open this tape. Yeah, there's red and bluish colored sheets here that, you know, you can kind of see through a little bit while this is together. And that give you kind of an idea of... Actually, no, you can't even see it. Huh. Then why do they bother using any colored sheets? That's really weird. Yeah, you can barely see. I mean, there's this little area here, I guess. You can see how much is left. So yeah, this is fascinating. Anyway, I'll see you guys later. And the plot thickens, so I just removed the outer clear spool and just had it feed some of this sticky back white portion. And actually, yeah, that's inside. The printhead never gets near that, so it's the clear outer layer that's actually printing on the inside of it, and then it sticks it to... All this is double-sided tape, essentially, with some paper backing. So yeah, that's fascinating. So yeah, it's the clear part portion, the inner part, it prints in mirrored so that, you know, you can kind of see it right way around. Yeah, so this is pretty darn cool. The jerkwads. They have a DC in 7 to 9 volt, you know, standard DC jack input, and they swapped. You always put positive on the center pin. Sleeve is always negative. Why do you swap them? Why would you ever make the center negative and the outer positive, other than to sell an overpriced adapter that you force people to buy who don't know any better? when all it is that the 2 pins are swapped. Why would you do that? Jerkwads. And I'll see you guys later.